Hi, Math 2 students. Today we're going to talk about perpendicular bisectors. So, a perpendicular bisector is a line, segment, or ray that divides a segment into two congruent segments. That comes from the bisector part, right? The two congruent segments. And it intersects to form a right angle. So if you recall, the word perpendicular means that two lines meet each other at a 90-degree angle. So if something is a perpendicular bisector, they're going to meet at a 90-degree angle, okay? And then, since BD is the bisector, it's going to bisect AC. So AB is congruent to AB, okay? So basically, it's kind of like two things going on. It's going to meet at a 90-degree angle. You're going to end up with two congruent segments. So we have, from this, we can make two statements. We can say that angle DBA is equal to 90 degrees, all right? And we can also say that AB is congruent to BC. And I guess also we could say that DBA is congruent to DBC. Ooh, I forgot the angle symbol. Because obviously that is also a 90-degree angle right there, right? So there's a lot we can conclude from there. All right, next one is perpendicular bisector theorem. So if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment. All right. So what does this mean? Again, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what they're showing here is that these guys are congruent to each other, okay? So the endpoints of this segment that is bisected, we have E and G, all right? The lines that connect the endpoint to this line that's bisecting, all right? Those are going to form a segment that are congruent to each other, okay? So from that, we can say that EF is congruent to FG. All right? So if we look here, all right, for our example, they want us to find Kn. So whenever you're presented a problem like this, you kind of just want to take a step back and be like, okay, what can I say? You know, can I say certain things are equal to each other? Can I add up certain things to equal something? Just kind of figure out what equations you can set up and what relationships you have between the angles or the segments. All right. So here, because we have that KB is a perpendicular bisector, okay, because we can see that it meets it at a 90-degree angle and it bisects this segment. We then can use this theorem here saying, or I guess I should have circled the perpendicular bisector theorem, that these lines that connect the endpoints to this perpendicular bisector are also congruent, okay? So we can say that 3x is going to be equal to x plus 10, all right? So we can solve. We get 2x equals 10. We get that x is 5. All right, so for this next one, they want us to find FG. Now again, we have a perpendicular. We can see it's perpendicular by the box. And we know it's a bisector because we have these little dash marks here. So they want us to find the measure of FG, which ironically is not on this diagram. So let's go ahead, we'll change the diagram to match what they're at. Or how about this? I'll change the question. How about we find the length of OU? All right. So with this in mind, what we can do is, because we know this is a bisector, we can set these guys equal to each other. So we're going to say 7x plus 2 is equal to 3x plus 10. We can go and solve minus 3x minus 3x. We get 4x plus 2 equals 10. 4x equals 8. We get that x is equal to 2. So then if we're trying to find OU, we have to use our x value and go plug it in. So I'll go ahead, I'll plug it into VU for right now. So we know that VU is going to be equal to 3 times 2 plus 10, which is going to be 16. All right, so if this is 16, we know that OU, which this whole thing right here is going to be double that, so we can say that OU is equal to 32. You just double the 16. All right, let's see. Next one, we have angle bisector theorem. So if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle, okay? So what this means here is they told us that we got angle DAB, and they tell us that AC is a angle bisector. And based on this theorem they just told us, if we were to connect any 2 points from the the sides of the angle, I guess, to the bisector, the distance is going to be equal. So that's going to be equal to that, okay? So we could say that BC is congruent to CD, all right? All right, so here, all right, it says find UI. Now, right off the bat, we have to make sure that we are even able to apply this theorem, right? So in order to apply this theorem, we need to know that we have an angle bisector. Now, they didn't tell us that we have an angle bisector, but because we know that these two angles are equal, we can conclude that RU is an angle bisector. All right, so because of that, we can then say, well, we know based on the angle bisector theorem that these two lengths are going to be equal to each other. So we can say 2x plus 5 is equal to 7x. We subtract 2x from both sides. We get that 5 is equal to 5x, and x is going to be equal to 1. And they want us to find the measure of UI. So we just got to go plug that in. 7 times 1, we get that UI is equal to 7. All right. Go ahead, let's try this one here. So, again, they didn't tell us that we have a bisector, right? But we know we have a bisector because of these little markings they did right there. So based on that, well, actually, additionally, we can conclude that these are congruent because of the little tick marks as well. So we can set these guys equal to each other. All right, we get 4x equals 16. We should get that x is 4. So if we're trying to find QA, we just plug that in. We get 12 plus 16. We get 28. All righty. Let's see. Now, looking at this one, okay, again, it's important when you're doing geometry problems that you have like a good reason for what you're setting equal to each other, okay? Now, right off the bat, we can't just look at this and be like, oh, these guys are equal, let's set them equal to each other. Okay, we have to have a good reason. Now, based on this, okay, we know that if a point is equidistant from two sides of the angle, then it is on the angle bisector, okay? Well, this point is equidistant from two sides of the angle. Therefore, we can say that YM is an angle bisector. Okay, and because of that, we know that these angles have to be congruent. So we just say 4x minus 1 is equal to 2x plus 5. We get 2x equals 6, and we should get that x is 3. So then we can go ahead. They want us to find WYM. WYM. We're just going to go plug that bad boy in, and we get 2 times 3 plus 5. We get 6 plus 5, and we should, oops, my bad. We should get 11 degrees.